Hi and welcome to this video where I'm going to explain how to answer exam questions relating to types of solids and their properties, which will be found in the NCEA Level 2 Structure and Bonding exams. Now typically these questions make up about 1/3 of your exam paper. So you should look to be able to answer one of these questions ideally in about 20 minutes. Typically, the question comes in about 3 parts. And there will be a table at the top with 3 to 4 substances where you'll be asked to identify the types of solid, its particles, and its type of bonding. And then there will be 1 or 2, or sometimes even 3, long answer questions which usually ask you to compare the 2 of the solids or 3 of the solids and 1 or 2 properties. So let me show you in a minute. I'll tell you a bit about how to answer this and give you a work through example. Okay, so here is the 2019 exam question. And you'll see at the top, this is a very standard example of this type of question. So we've got the table to complete. First off, in this case, we've got 3 substances, sodium, sodium iodide, and iodine. And again, having those 3 substances related to each other as they are there is fairly common. And then there are 2 long answer questions. The first one is comparing the fact that sodium is malleable while sodium iodide is brittle. And the second one is talking about the solubility of iodine in both water and cyclohexane. So both of them are effectively compare type questions. So how do you go about answering a question like this? Well, the first thing you need to do is you need to be able to answer the table, because actually that gives you a whole bunch of clues that will help you develop the rest of your answer. And then for each of the long answer questions, what you really want to do is start off by stating what type and describing the bonding present within the molecule or compound or substance of whatever type it is. You're going to explain what are the requirements for that property. What does it take for something to be electrically conductive or soluble or brittle or malleable or have a high melting or boiling point or whatever it happens to be. And then you're going to relate the bonding to the property, and you'll do that for each of the substances in the question. And you can finish off, if required by the question, with some kind of a comparison. Okay, so let's look at the table first. Okay, here's the start. Okay, so the first thing, and you really have to be able to do this, is to identify what types of substances we've got. So looking at sodium first, the question you have to ask yourself is sodium a metal or a non-metal? And hopefully by looking at the periodic table, you'll be able to see that it's a solid, it's a metal. If it's a metal, it's made up of atoms held together by metallic bonding. Sodium iodide has 2 types of atoms present, sodium and iodine. Sodium, we've already decided it's a metal. Iodine, hopefully by looking at the periodic table, you will realise is a non-metal. And so having a metal and a non-metal present means it's likely to be an ionic compound, which means it's made up of ions held together by ionic bonding. And finally, if we've decided that iodine is a non-metal, then iodine must be a molecular substance which is made of molecules held together by intermolecular bonding. This table and the information on it provides you with the clues that you need to answer the rest of the question. So here we go. Sodium is malleable, whereas sodium iodide is brittle. Explain these observations by referring to the bonding and structure of each substance. So all you're going to do is talk about sodium and why it's malleable, and sodium iodide and why it's brittle. That's all this question is asking. So sodium is a metal. We already decided that. And now we're going to describe metallic bonding. So it consists of metal atoms surrounded by a sea of delocalized valence electrons through non-directional bonds, or with non-directional bonds, or something like that. So that's stating the type of solid, explaining the bonding. Now we're going to talk about why sodium is malleable. When a pressure is applied to a piece of sodium, the atoms and electrons are able to move without disrupting the non-directional bonds, which allows it to change shape or be malleable. That's all that's required. And then we're going to do the same thing for sodium iodide, which we've already identified as an ionic solid. So, sodium iodide is an ionic compound made up of alternating anions, I-, and cations, Na+, held in a rigid 3D lattice by directional ionic bonds. If a force is applied to sodium iodide, it will move the ions so that ions of like charge are aligned. This will cause them to repel each other and the structure will break. Therefore, it's brittle. That's it. That's an excellent answer. That's all they're looking for. The two substances described with their bonding. So it's when you know how to answer it, and there's some fairly standard things to put into there, it's not an overly complicated question. But you do have to get it pretty much all correct. Okay, you will get pinged for missing out even just little parts of this answer. So this is where the difference between merit and excellence becomes quite picky. Okay, and then part C, compare the solubilities of iodine in water, a polar solvent, and in cyclohexane, a non-polar solvent. Now there's a really big hint here. By talking about a polar and a non-polar solvent, it means we have to talk about whether or not iodine is polar. Because whether or not iodine is polar is going to affect whether or not it dissolves in water or cyclohexane. So that's the first statement that we're going to make. It says compare the solubilities. That's the first thing we have to do. We have to compare the solubilities. Is it more soluble in water or is it more soluble in cyclohexane? Well, iodine is non-polar because the only bond is between the two iodine atoms, which are the same, therefore there's no difference in electronegativity, therefore it's non-polar. So it will be more soluble in non-polar cyclohexane than in polar water. Okay, so that's that first point done. Use your knowledge of structure and bonding to explain the solubility of iodine in these two solvents. So now we've compared, now we have to explain. Right, so in water, the attractions between the nonpolar iodine molecules and water are weaker than the attractions between the iodine molecules themselves or between the polar water molecules. So iodine does not dissolve well in water. Ideally, you can use words like solvent and solute in this, but the key thing is getting the idea that the iodine molecules are more attracted to each other than they are to the water, and the water molecules are more attracted to each other than they are to the iodine. You can use as many words as you like to answer this. I think they give you about a page all up, but this is the key stuff that they're looking for in their answer. And in cyclohexane, however, and I like using words like however because they show linking of ideas, the attraction between the nonpolar iodine molecules and the nonpolar cyclohexane molecules is stronger than the attractions between either the iodine molecules themselves or between the cyclohexane molecules. So iodine will dissolve in cyclohexane. Now you'll notice that this is not an essay answer. These paragraphs are not structured well, and in fact they're really just a couple of sentences each. It's not all about the writing in chemistry. We don't care if you can structure a good answer. All we care about is, do you know the chemistry and can you explain it properly? So this is a second excellence answer. It is as much detail as you are required to put in there. Again, like I say, if you can use words like solvent and solute, then that's great, but it is not essential. So that is how you go about answering basically 1/3 of the exam paper, all about the structure and bonding of different types of solids and how this affects their properties. I hope you found this useful, and I hope to see you again soon when we start talking about the energy changes, which is the final third of this topic. So we've talked about all the other parts. I hope to see you again soon. Until then, bye.